What if I tell you that we are going to understand or study a concept which is really, really important in generative AI? I would say it is the backbone of generative AI and any future systems or any future studies that you'd be doing in generative AI. If I talk about vectors, vector databases, or we'll go and study the concepts like RAG. So it's very important that you understand what is embedding. So embedding is a way of converting the features of an object, like a word, into a vector of real numbers. Now, this is quite a theoretical definition, if you see. So it says vector is embedding is a way of converting the features of an object. So what you're doing, the main thing is converting the features of an object like a word into a vector. So vector you can think of is nothing but numbers. We will go and understand vectors in more detail, but for now just understand it is nothing but some numbers. Now this is I would say more theoretical, but to understand it properly, I would suggest that if you focus on this diagram, right? So what it says is, let's say we take an example of a cat. Now a cat has several features, or we can try and give a specific numbering scheme or specific numbers can be given based on a certain feature, right? So living being is a feature. Feline means that whether it belongs to a particular family, like tigers, cats, they belong to, or lions, they belong to the same family of animals. Then human is another category or a feature. Gender is another feature. Royalty, verb, or a plural. Like, so for one word, it is saying that it could be put into different categories or different features, right? And based on that, it's actually giving some numbers. So if you see living being, it gives a 0.6. There would be something like an embedding algorithm that it goes through. And for things like royalty, verb, it gives a negative, which it feels that it's a negative. But if you see houses, for houses, it will give, for a plural, it will give a positive number, right? Same way, what it is doing for kitten, right? So it is a living being. It is of the same family. You'll see that it is quite close. This is 0.9. This is 0.8. Then we look at the gender. Again, it could be gender based, whether it's male, female, and other things. So same way what we've done is we've done cat, kitten, dog, houses. And what it says is these are something like, you can say it as a 7-dimensional, right? Because we are studying 1, 2, 3, 4, 5, 6, 7 different features. Now it's very difficult to actually work in a seven dimensions, right? So what it says is then it has to go via a dimensionality reduction, right? So what it does is, with this reduction of the word embeddings from 7D to 2D, so we are going from 7 dimensions to 2 dimensions. So this is a process where a complex, high dimensional data is transformed into a lower dimensional space. So we are going from 7 dimensions to 2 dimensions to make the data easier to visualize and work with while preserving. Very important, guys. You are breaking the data so that it is easier to visualize and work with, but you are preserving as much of the significant information as possible. So you are still kind of preserving much of the significance of that word or those number of different features combined together, right? So this is how it would look like. Now, if you see, now if we look on the right side, so on the right side of the diagram, you'll see there's a visualization of the word embedding in 2D space after the dimensionality production process. So this shows how the words with similar meanings or relationships are grouped together. Very important. It's not only the words with similar meaning, but words that are related to each other are also grouped together. So in a 2-dimensional space, if you see, a cat and a kitten are closely set closely to each other. But if you see a dog is far away from this. Even houses are far away from it, right? So then you have also pairs. So it's another important thing here. It is if you're looking at the features of a man, a woman, a king, or a queen, right? So you'll see a man has a lot of features that are similar to a king. So if you see a living being, yes, it's so the numbers are quite similar, right? If you see human 0.8, 0.7, right? Then even if you go to gender, it's 0.9, 0.8. So they're very similar, right? So then it is saying you can also have, so one is like cat and a kitten, which like they are closely related to each other. But there could be another relationship where we are saying a man, as a man is related to a woman, a king is related to a queen, right? This is the whole beauty of context. When we say the generative AI systems understand the context, it is all about they understand the meaning and the context of that word that you are working on. So how it goes is, here you have a word, right? So the word, from a word, we are creating a word embedding, right? Which is nothing but a collection of numbers. Then you reduce that. So from 7D, you are going to 2D, right? And then it is a visualization of the word embedding in a two-dimensional space. This is how it looks like, right? So let's quickly take a look. So when we talk about embedding, we are transforming the data. So embedding turns complex data like words or pictures into vectors or a list of numbers that a computer can understand. Now, we always know from our basics that computers always understand numbers. Now, these numbers are what we are talking about here is that you're breaking a complex word, or it could be a picture tomorrow, right? Here I've given an example of simple words like cat, kitten, dog. You could even give the input as a picture. So all it is doing is it is dividing the data or turning the complex data into vectors. Vectors is nothing but again a set of numbers that a computer can understand. And as we just studied here, your purpose is to understand the similarity, right? Similarity. Like as I said, a man is to a woman, a king is to a queen. These are kind of similarities. Or a cat and a kitten are closely related to each other rather than a dog or a house. So they help find similarities between items. For example, in word embedding, similar words are represented by numbers that are close together. Like we took an example of cat and a kitten, right? Very important thing, they help to make big, complicated data simpler. As I showed you, like we were talking about 7 dimensions, the 7 different features of a cat, kitten, dog. It helps to break down or make the data smaller in terms of simpler and smaller data, which is easier for computers to understand, right? So that's why you're working on it. And embeddings are used everywhere. Like it helps the computers understand language or recommend things you might like, right? So recommender systems that you are having. So everywhere you will see that embeddings are getting utilized. Now, there are different models or you can say even which are based on different algorithms. So different types of embeddings which are quite popular today are word-to-vec or word-to-vector, which was released by Google. Then you have the GLOVE, which is the global vectors for word representation, and you have also a very well-known embedding type, which is BERT. BERT stands for bidirectional encoder representation from transformers, right? So the other thing is that computers can learn to create these embeddings by looking at lots of examples. So from the very beginning, I've told you in machine learning, deep learning, the magic is your data quality and data quantity. And the machine learning algorithms need to learn from data. So the more data you give, the more or better learners your model can become, right? So that is what we are saying. So computers can learn to create these embeddings by looking at lots of examples, which helps them understand and predict new unseen data, right? And yes, some advanced embeddings can even understand the context, because that's anyways I would say the backbone of Gen AI systems. Because we learned about bank, right? We said bank of a river and money in the bank. So it's the same word but in a different context or a different meaning, right? So these advanced embeddings can help understand the context, meaning they can tell the difference in the meaning when a word is used in different ways. So as I gave you the example, bank of a river and money in the bank, right? Pretty simple. So again, if I take a very simple example and if I say, where would you place an apple in this two-dimensional space? Obviously, you'll actually look at the features, right? This is a football. This is, say, a basketball. So they come under, they are close to each other. They fall in category A. Then we have a category of B, which is of houses. Then we have category where, let's say, which has wheels, like you have a bicycle, you have a car. Now, apple obviously falls in the category of fruits because you have strawberry, you have banana. So the features or the different features that you have for different fruits are similar for apple as well. So it falls under the category of C. So I think with this, you would have got a good understanding of what is an embedding. So very simply, just take embedding is nothing but it is a simple way in which you are converting the features of an object like a word into a vector of real numbers. So in the next video, we will try and understand what are vectors. Thanks for watching.